In this video, I'm going to show you how to solve the ALEKS problem called Interconverting Derived SI Units. So this problem is a unit conversion, but it is definitely not a simple unit conversion. This is a pretty complicated one. So I'm going to begin by rewriting, just so we have more room, I'm going to begin by rewriting the number that has been given to me, 0.0579, and the units, kilopascals, over kilometers. So I'm going to rewrite it in a more conventional format, in a fraction format, rather than kilometers to the -1. Now my goal is to convert this number into units of kilojoules over meters to the fourth, and that's what I'm going for. And this conversion factor from pascals into joules is not a super straightforward conversion process. And I'm pretty sure if you go into the ALEKS data tab, it probably isn't a conversion factor to go between pascals and joules. So this is something that you're going to have to kind of go step by step. Now my suggestion when you start working on this problem, my suggestion is to begin by removing any metric prefixes that are on any of your starting units. So for me, that means I want to get rid of the kilo part of the kilopascals, and I also want to get rid of the kilo part for kilometers. I'm going to strip away all of my metric prefixes. That's going to make this problem easier to solve. Step number one for me, I'm going to get rid of the kilo part of the kilopascals. So I'm going to convert kilopascals just into regular pascals. We know that kilo is the prefix for 10 to the 3. That means 1 kilo is 10 to the 3, whatever it is that we're talking about. That's going to get rid of the kilopascal unit. And I'm going to do the same thing for kilometer. I'm going to strip that thing down to just a kilometer. So I want the kilometer unit on top of my conversion factor. That way they will cancel each other out. And I'm going to convert into regular meters. Kilo, again, is the prefix for 10 to the 3. So 1 kilometer is 10 to the 3rd meters. And that cancels out the kilometer unit. So now I've got my units down to pascals over meters. Now let's talk a little bit about pascal and also joule as well, and in fact whatever funky units ALEKS is giving you to convert with maybe isn't going to be pascals and joules. These are units of units. So these are units that have their own units in them. The next step for you, for me, is to look up the units of the unit pascal. And I'm just going to use the internet to do that. What are the units of a pascal? I'm just going to use the abbreviation. And we're going to go, I'm going to go to Wikipedia because it's going to have it in the cleanest format for me. So if I go down to this general information about the pascal, notice here it has an entry for the base units, the SI base units of a pascal, and there they are. So I'm going to make a note of that. A pascal, the units of a pascal are kilograms over meters times seconds squared. I'm just reading that right there. Those are the units of a pascal. And this is what we are going to use next to get rid of this pascal unit. So this is kind of, in this format, not super helpful in this format. So we're going to rewrite this equality, pascal equals kilograms over meters times seconds squared. We're going to rewrite this as if it were a conversion factor. So I'm going to write it as pascals over kilograms over meters seconds squared. It's a fraction of a fraction. That's kind of ugly. But this is going to allow us to convert out of pascals into normal units. So what we want to do next is apply that conversion factor that we just created to get rid of that pascal unit. Right now, our pascal unit is on the top, so we want a conversion factor that puts the pascal unit on the bottom. Bummer, this conversion factor that I just wrote has the pascal unit on the top. That's okay. It's all right, because we know with conversion factors, we can flip them upside down if we need to. So we're just going to make the numerator into the denominator and make the denominator into the numerator. That's totally valid if we're using this as a conversion factor. So 1 pascal is 1 kilogram over meter second squared. I put these ones in front here just because it makes me feel comfy. When I have conversion factors that are just units with no numbers associated with them, I don't know why, but it just makes me feel uncomfortable. Ones don't need to be there, but I guess I need them there. So this is going to cancel out the pascal unit. Now I've got myself in a weird little pickle because I have a fraction within a fraction, which is also something that makes me feel a little bit uncomfortable. When I have a fraction in the numerator, and you're only allowed to do this when it's in the numerator, when you have a fraction in the numerator, you can actually just take that fraction. I'm gonna square this fraction up a little bit. Kilograms over meters second squared. So when we have a fraction that's in the numerator, only if it's in the numerator, we are allowed to just move it on down like a regular old fraction, just like that. Whew. Okay, so here is where we are at. We are at kilograms over meters, and a second squared unit. Now, this is not what we're trying to convert into. We're trying to convert into kilojoules over meters to the fourth. Kilojoule, like Pascal, is another unit of units. So let's go back to the internet and let's take a look at what the units are of a kilojoules. Units of, well, actually we're going to look for the units of joules, not kilojoules. I don't know what just happened there. Units of joules. And again, go back to the Wikipedia page because it's nice and clean and easy to look at. And it's going to tell us what the base units are. For the joule, here we go. We're going to do the same thing as we did up here. A joule, according to Wikipedia, is kilogram meter squared over second squared. And we're going to turn that into a conversion factor, just like we did for the Pascal. So we're going to say a joule over kilogram meters squared over second squared. Whew. Okay. All right, so here's a conversion factor that we can use if we were in a situation where we wanted to add the joule unit into our the units of our answer. We can see that we want, this is the part where it's going to get really weird, we want ultimately to have the joule unit up on top of our final answer. So what I'm going to do is take this conversion factor and I am just going to stick it in here. I don't know what it's going to cancel. I don't know what it's going to do, but I'm just going to stick this conversion factor right into the problem. There's no ones in front. It makes me feel really uncomfortable. And the reason that I'm doing this is because I can tell that ultimately I want that joule unit in the numerator of my answer. So I'm just going to take this and I'm just going to put it right in and let's see what happens in terms of cancellation of my units. Well, I've got a kilogram. Oh gosh, I've got a fraction. I've got another fraction in a fraction again. Yikes. So when we have a fraction in our denominator, we are not allowed to do the same trick that we did last time. We're not allowed to take this guy and just move it up like a regular fraction. We actually have to invert it. So if we have a fraction in the denominator, we are going to need to invert that fraction. The second term, second squared in this case, is going to move, without that, the second squared is going to move itself up to the top. That's how we're going to get rid of the fraction this time. Okay, so we're ready to do some unit cancellation. The kilograms are going to cancel. The seconds squared are going to cancel. And oh my gosh, things are looking really good for us. We've got our joule in the top, which is where we want it. And we have 1, 2, 3, 4 meter units in the bottom. We're almost done. The last thing that we need to do is convert this joules into kilojoules. That seems super easy compared to the stuff that we have been doing. We want to get rid of joules. We want to convert into kilojoules. Kilo is the prefix for 10 to the 3, so 1 kilo is 10 to the 3 joules. And this is now going to give us all of the units that we want. Whew. The last thing that we need to do is actually carry out the math, all of the math on this. Numerically, let's take a look at what's happening mathematically. We have this 0.0579. We're going to multiply it by 10 to the third and then divide it by 10 to the third. So let's just not even do that at all. So we have 0.0579 divided by 10 to the third. 0.0579 times 10 to the negative 3. I guarantee ALEKS won't like you entering it in this particular format, but I don't think it'll mark it wrong. But it probably would be wise to enter it in a traditional scientific notation format just to keep ALEKS from being too cranky.